Okay, good morning, ladies and gentlemen. This is the 6th week of our academic semester. If you remember, on the previous seminar, we talked about contingency tables, ANOVA, analysis of variance method, both methods in descriptive way only, yes, without statistical testing, only descriptive way. And descriptive analysis of dependence, yes? And after we continued with regression models, linear regression models, we estimated regression line, we estimated quadratic regression function, regression parabola, yes? And of course, the regression plane, where we used two variables, two explanatory variables, and after we continued with introduction to time series analysis, simple time series analysis. I showed to you basic measures, characteristics of dynamics. Yes, first differences, coefficients of growth, mean first difference, mean growth coefficient, yes, and simple average from the time series. And after I continued with talking about decomposition of the time series. Today we will continue. There is a first example in Microsoft Excel. First example in Microsoft Excel. The table below shows the number of seasonal employees, temporary workers in the car factory. Number are valid on the first day of the particular month. So we have here months from January to December, yes, and observed variable in time t is number of temporary workers, yes, and the number of temporary workers still change, yes. In summer you need more employees, in winter you need less employees, so the values are different and we would like to calculate the mean. But you know that each month, yes, has different number of days, yes, different number of days. Either working days or current days, but different number of days. So we need to know these lengths, yes, these days. We will set, yes, we will set here another column with number of days, D1, D2, D3, D4, D5, D6, D6, D7, yes, until D12. We know that January, yes, January has 31 days. Yes, February we will use basic. We will use common year with 28 days. So D2, 28, yes? January, February, March, 31 days. January, February, March, April, 30 days. January, February, March, April, May, 31. January, February, March, April, May, June, 30. July, August, 31, yes, so D7 and D8, 31 and 31, D9, D10, D11, D12, so D9, January, February, March, April, May, June, July, August, September, 30, October 31, November 30, and December 31. Yeah? So we have here another column with number of days, yes, and we'll use chronological mean, which is written in our formulas. It's the largest formula here, yes. So in nominator, we have a lot of partial calculations. Y with stripe, yes? Y with stripe is equal to what is necessary for us? First observation and the second observation. Y1 plus Y2 divided by 2. This is, you can imagine that this simple summation divided by 2 is moving average. Yes, this is moving average with length 2, yes, weighted by D1. Yes, it's a moving average with length 2, weighted moving average. So Y1 plus Y2 divided by 2 times D1. And we will continue, yes, we will move, because this is summation of weighted moving average with length 2. So second is Y2 plus Y3 divided by 2, weighted by D2. And we will continue. I will write the last formula, the last partial part, the last partial yn minus 1, so November, plus yn, the last observation, December, divided by 2, and this is weighted by dn minus 1. We know that n is equal to 12 months, yes? 12 months. So there was yn minus 1 plus yn. I need more space. Yes, sorry, I need more space on the whiteboard. So yn minus 1 plus yn divided by 2, weighted by dn minus 1. Yes. So this is numerator. Yes. This all is numerator, and this is divided by summation of weights. Yes, summation of days, number of days. That is D1 plus D2 plus D3 plus, and the last length is November. Yes, in this situation, plus dn minus 1. Yes, in the formulas you can see that last is dn minus 1. So number of days in we don't need number of days, yes, here in December, D12. Okay, so I need more space, so I will leave only these 4 values on the whiteboard. Yes, I will delete the rest. So please wait a second. Please wait a second. Okay, so chronological, weighted chronological mean. First observation, 31, yes, plus, sorry. First observation, 140 employees, yes, 140 employees, plus 138 employees, divided by 2, yes. Simple moving average with length 2, yes, but weighted by D1, 31, yes. So this is the first part, plus, and we can continue. 138 plus third observation, 115 divided by 2. Weighted by 28 plus, yes, and we can continue. Last partial part will be 143 plus 130 divided by 2, weighted by 30 days, November, yes? 30 days, November. Okay, so this will be numerator, and this is divided this is divided by summation of days from January to November. Yes? So 31 plus 28 plus, and the last observation is November, 30 days. Yes? 30 days. Okay. So I will delete this part from the whiteboard, and here in Microsoft Excel. So there we have the partial calculations. So weighted moving averages with the length 2. Yes. That is summation. So this is nominator. Yes. So nominator y with stripe is equal to nominator 093 divided by number of days without December, 334. The result, almost 147 employees. Yes. So if we use only one decimal, yes, result is 147 employees, workers, yes, seasonal workers. So this is average, weighted average. Yes, it's weighted chronological mean because we don't have the same length. Yes, in intervals, in observations, different months. Yes, different months has different number of days. If we calculate only simple mean, yes, please calculate here just average, equal sign average. Average returns the average. Yes, classical mean result will be different. 146. Yes, almost 146. 145.8. Yes. 145.8 employees. This is wrong. Yes, because we have different number of days, the months. So please don't use classical mean. Yes, you must use this weighted version of chronological mean. So we calculated the average number of these workers, seasonal workers, over the year. Okay, another example, see the sheet 2. So we will look to the sheet 2 in this Microsoft Excel. There we have vital statistics of the Czech Republic. This is a sheet, a table, which is published by the Czech Statistical Office. Yes, demographic table with demographic data. There is a lot of vital statistics in absolute monthly figures, absolute observations. And you can see that there is a column about net migration. What is it, net migration? It's a difference, simple difference between immigrants and emigrants. Yes, you can see that in the Czech Republic between years 2015 and 2016 we had all values. Yes, all values of net migration positive. So there is a positive increase. Yes, positive increase by migration in the Czech Republic, and we will use these 24 values. Yes, we will use these 24 values, monthly published data. So we will again look to sheet 1. I copied these values for you, so you can see the behavior year 2015 from January to December, and year 2016 from January to December. So 24 observation in total. This is monthly published time series, monthly published data. Observed variable is net migration. number of people, yes, net number of people, positive increment, yes, of a number of inhabitants in the Czech Republic by migration, yes. So we'll use monthly published data about the net migration in the Czech Republic between year 2015 and 2016, and we would like to transform this time series, monthly time series, to quarterly time series. We must think about this variable, yes? What is it? Number of people, yes? Net number of people, increasing of inhabitants. So in January there is a positive increasing of the number of inhabitants, increasing by 1,384 inhabitants, yes, in total. In February, another increasing, yes, in March, another increasing, etc. So we know that monthly time series has 12 months, and quarterly published time series has 4 quarters. Yes, first quarter, second quarter, third quarter, fourth quarter, spring, summer, autumn, and winter. Yes, so we can calculate simple summation of 3 months. January plus February plus March. Yes, January plus February plus March is the first quarter of the particular year. Yes, because the variable represents the number of people. Yes, and we are allowed to calculate the summation of people. Yes, so there is not necessary to calculate any mean. It's a simple summation. Yes, so year 2015, first quarter, second quarter, third quarter, first, second, third, fourth, yes. So just simple summation, and because the variable is number of people, we have dual numbers. Yes. So for I will write for you the first step. Yes, January 1,384 plus 1,461 plus 1,544. Yes, and this is first quarter. Yes, here 4,389. 4,389. And we can continue. Yes, we can continue the summation April, May, June. Yes, third quarter, the summation July, August, September. Yes, fourth quarter, summation October, November, December. Yes. And we will continue with year 2016. Yes, so again, January, February, and March, first quarter, yes, of the particular year. Second quarter, summation of April, May, and June. Third quarter, summation July, August, September, and fourth quarter, October, November, December. Yes. So we have here 8 new values. The table with quarters, please. Okay. We will move these tables, these small tables, to the middle, because we will need these tables only. Yes. We don't need these tables anymore. But maybe chart. We will look on the chart. Yes. Please show me the chart, the line chart of the, for example, year 2015. Yes. Simple line chart. Yes. Okay. There we have January. From January to December, you can see this decrease this decrease in the statistic between June, July, August. This is summer, yes. This decreasing is not because in summer people don't want to move, yes. But there we have statistics, yes. And statistics are written, saved, yes, when the officer, yes, write this event to the system, yes, and because in summer, yes, officers have a vacation, yes, there is a small amount of papers and issues ordered by these officers, so there it is decreasing, yes, and after September, October, November, yes, all papers and administrative issues are solved, yes, and statistics are recorded, yes, statistics are recorded to the system and published in particular sheets. So this decreasing is here, visible here, almost every year, yes, because of vacation in offices. So it's just only illustration. So I will clean the whiteboard and I will rewrite quarterly time series on the whiteboard. Yes. So year 2015, first quarter, second quarter, third quarter, fourth quarter, and year 2016, first quarter, second quarter, third quarter, fourth quarter. Yes. So from 24 values, we have now 8 new values. So 4,389. 4389. Second value 3102. 3102. 2651. 2651. 5835. 5835. 5293. 5293. 4973. 4973. 3610. 3610. And 6188. 6188. Okay, quarterly time series. Smooth quarterly time series by appropriate moving averages. Write down on the paper all the first calculated values of these moving averages. What is a moving average? We can have even moving averages and odd moving averages. Yes. So even and odd. Yes, even and odd. If the length of the time series, the length of seasonality is odd, everything is easy, everything is simple, because in case of odd length, yes, there is a median. There is a median, the value in the middle, yes, value in the middle, and the result can be placed, can be right to the middle, yes. But now we have seasonality, yes, quarterly seasonality. So there we have 4 values, yes, of the particular year. So 4 is even. Yes, 4 is even. So if we calculate the moving average with the length 4, we don't have a position where to write the result. Yes, there is not position where to write the result. So it's a little bit more complicated. Okay. So moving average. Yes. Moving average, for example, with the length 3. What is it? X. Sorry, I will take a better marker. X1 plus x2 plus x3 divided by 3. Yes, this is moving average with the length 3. Moving average with the length 5. Yes, for example, x1 plus x2 plus x3 plus x4 plus x5 divided by 5. Yes? Etc. 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 There we can see moving averages. But this is quarterly time series. We must use moving average with line 4. So we will start with calculation. We will start with calculation x1 plus x2 plus x3 plus x4 divided by 4. Yes? And we will continue, we will move. Yes? We will move because moving average. Another calculated value will be x2 plus x3 plus x4 plus x5 divided by 4. Yes? And we will continue, we will continue, we will continue. Okay. Okay, so we will start moving average, yes? So with the length 4, so these 4 values, the sum of these 4 values divided by 4, yes? So the first part will be 4,389, yes, plus 3,102 plus 2651 plus 5835, yes, and this is divided by 4, and we will continue, yes, according to this schema. So I will delete these formulas and we'll continue. We can move, yes, it's moving average, so we will move down. Yes, we will move down. Another partial result. 3,102 plus 2651 plus 5835 plus 5293. 5293, yes, and this is divided by 4, yes, and we will continue, we will continue, we will continue. Another part, yes, you can see these values, yes, these 4 values, etc., etc., etc. In Microsoft Excel, you can check, yes, you can check that there is a summation. I will zoom this document. There I have summation of 4 values divided by 4, yes, and what is here? Summation of these 4 values divided by 4, yes. And we can continue, and we can continue. The last value is here. Why? Because there is summation of first quarter, second quarter, third quarter, fourth quarter, year 2016, yes, divided by 4, and I don't have other observations. So there is the end. Yes, 5 partial values. I will write these partial values on the whiteboard. Okay, we will write these partial results, partial values on the whiteboard. So there, yes, will be value 3994. 3994, yes. Another value 4220. 4220 will be here, yes. Third value 4688. 4688. Fourth value 4928. 4928. And last possibly calculated value will be here, 5016. 5016. Okay, and we will return the information which was said at the beginning, odd, yes, and even. Odd and even. There, this is quarterly time series, so even length of the time series, yes. If we calculate moving average with the length 3, yes, or 5, odd, yes, odd length, the result is written on the position of median. So there is first value, second value, third value, and the result of moving average of the length 3 will be placed on this position, yes, on the position of median. If we calculate moving average with the length 5, 1, 2, 3, 4, 5, summation of these 5 values, median is here on the third position, there will be written the result, yes, and this will be the end, yes, but this is even length, yes, there is position in the middle, yes, but there is not the cell, yes, I don't have a position, a cell where to write the result, so we must continue, yes, we must continue, we must calculate the simple average, the simple mean of these two values, yes, and this will be the final result. So 3, 9, 9, 4 plus 4, 2, 2, 0 divided by 2, yes, and we can continue 4, 2, 2, 0 plus 4, 6, 8, 8 divided by 2, yes, and we can continue 4, 6, 8, 8, 4, 6, 8, 8 plus 4, 9, 2, 8 divided by 2, yes, and last possibly calculated result is 4, 9, 4, 9 to 8, 4, 9 to 8 plus 5, 0, 1, 6 divided by 2, yes. We can use calculator or we can calculate the results in Excel. So I will sit here and I will zoom this table. Yes. Okay, so there will be calculated this value plus this value divided by 2. Yes. And result is 4107 is in peoples, yes, people, so I will not use decimals, yes, because result is number of persons, number of inhabitants, so all numbers, yes, you can see that there is the end, yes, and I will rewrite these results on the whiteboard. So 4107, 4107, 4454, 4454, 4808, 4808, and finally 4972. 4972, yes, and we will return here what was stated here, smooth the quarterly time series by appropriate moving averages, write down on the paper only the first calculated values of these averages. So it's very important to know that we calculated even length, yes? So there is not the end, yes? Most of students write on the paper the first calculated values, these values, yes? First value, second value, third value, fourth value, but this is wrong, yes? This is wrong because we don't have a median position here, so we must continue and we must calculate it simple average, yes, the simple mean between two neighborhood values, yes, and this is the final result, yes, and there is written write only the first four, only the first. There is not written four. Write down on the paper only the first four calculated values. First four calculated values of these averages. Yes. You are not able to calculate more values. This is first value, this is second value, third value, fourth value, and we don't have more data. Yes, we don't have more data or calculated more values of the moving averages. So this is a typical situation. The calculation of moving averages, moving average with the length 4, even length. Yes, odd is more comfortable, more easy because you have a median position where can be written the result. Okay, we can continue. We'll use monthly published data about marriages and divorces in the Czech Republic in year 2016. Again, you can check sheet 2. This is original data sheet published by the Czech Statistical Office, the official authority in the Czech Republic. So real statistics. Yes, we have here real statistics. You can check these values, and I copied these values for you here to two columns: marriages and divorces. So monthly published data in year 2016. We will calculate base indices and chain indices. It is necessary to set, yes, to set the base, yes, the basic period, yes, which will be constant. What is it? Classical chain index. We calculated on last week. We calculated growth coefficient. Yes, you remember growth coefficient? There, KT. Yes, KT growth coefficient. Y in time t divided by y in time t minus 1. Growth coefficient practically, yes, are chain indices, yes, because we are calculating the simple ratio, yes, y in period 1 in period 2 divided by y in period 1, yes, why? Because this is y in time t divided by y in time t minus 1, yes, and we will move through all time series, yes, we will move through all time series. So we will continue y in time 3 divided by y in time 2, and y in time 4 divided by y in time 3, yes, and still this is y in time t divided by y in time t minus 1, yes, and we can continue. So there we have a chain indices, yes, so this will be chain indices. result is relative number. Yes, relative number, which can inform us, yes, about relative increasing or relative decreasing between the particular months, yeah, because this is monthly published time series. Base index, base indices, base. We have a deal, yes, that the base will be January, yes, January, every time January. So this will be observation Y in time T divided by observation Y in January, yes, January. And we will continue, yes, we will continue another observation Y in time T, yes, in the particular row divided by Y in January, yes, in January. So we can continue, so there will be Y in time 2, so observation in February divided by observation in January, yes. And what will be here? There will be observation Y in time 3. So what is Y in time 3? March, yes. So there is February, and there will be March. February divided January, and there is Y3 March, yes. March divided by January, yes. Y in January. Okay, so we will solve this in Microsoft Excel. So, chain indices, yes. You can see marriages, chain indices, marriages. February divided by January, yes. And we can continue. What will be here? There will be March divided by February, yes. There is March divided by February, and we can continue. There is April divided by March, yes, etc., etc. And last observation, we have here December divided by November, yes. We don't have more data, and you can see we lost the first observation. So chain indices, we lost the first observation, yes? So we know how to calculate chain indices. Y in time T, observation in time T divided by previous value. We are using here 2 decimals. We can interpret the results, because result is a relative number, yes, relative number. So what is higher than 1, it's increase. What is below than 1 is decrease. So 1.25 means that between January and February, yes, the number of marriages increased by 25%, yes. There is 25 increasing between months, yes, between January and February. 0.76, it's decrease. There is decrease by 24%. Decrease, there is decreasing between April and May, yes, between April and May, number of marriages decreased by 24%, yes. Between June and July, number of marriages decreased by 11%, etc., etc. This is complicated because 3.05, there is increasing 205%, and this is outlying value, because you can see increasing from 1,341, yes, on value 4,089, yes. So This is complicated, but we can say that there is increase by 205%. Yes, but it's still relative number and information about increasing and decreasing between months. Yes, because this is a chain index. So increase or decrease is between months. There we have the development of base indices, and our deal is that the base is set on January. Yes, January is basic period, so we are comparing all other months with January. Yes, so 25% increase. Yes, the values are the same because we are comparing February and January. But here, 40% increase. There is comparison March with January, with basic period. Yes, so in March, yes, we had 40% more marriages in comparison with January, with basic period. Yes. 327% increase, increasing in April in comparison with January. Yes, January, winter. Yes, small number of marriages. Yes, so you can see that these indices are very large. December, again, winter. Yes. And people rather think about Christmas than marriages. Yes, so 24% more, 24% increase in comparison with basic period with January. Yes, so base indices using the base fixed value in Microsoft Excel. You can see in this formula that we have fixed denominator by dollars. Yes, if you open this formula, you can see that we have the dollars. Yes, and January is fixed, it's constant. So we can do the same for divorces. Yes, we can do the same with divorces, chain indices. Yes, observation in time t divided previous observation. Okay, yes, 2,191 divided by 1,950, and we can continue. Yes, again, results are relative numbers. I will wait for the calculation. Yes, dollars. Okay, so please check, for example, this value 0.99, open the formula, 0.99, this value. April divided by March, yes, April divided by March, result is 0.99, 1% decrease, yes. Between March and April, number of divorces decreased by 1%, yes. There, 1.05, there is increase by 5%. Between July and August, number of divorces decreased by 5%. Yeah? So we have here comparison between months comparison. And base indices, the base is January. Yes, base is January. All the time. So this value 1, for example, this value 1.16, for example, yes, 1.16 April divided by January, yes, April divided by January, result was 1.16, so 16% increase of divorces in comparison with basic period, with January, yes. The basic period is our deal, yes. We can have a deal that the basic period will be June, yes, February, etc. We can draw image, picture, chart of the development of indices, mainly the base indices, yes. You can see that the start, the first position is 1.00, Marriages are the blue curve, divorces the orange curve. So you can see the development of these base indices, where the base is set on January. Yes, divorces are more constant in the time, and marriages, yes, are more volatile. There is more significant seasonality. Yes, seasonality in the case of marriages. People mostly wants to get married in summer. Yes, and see that in summer there we have 800% increase. Yes, more than 800% of increase of marriages in comparison with January. Yes, so you are also able to watch the structure and the strength of the seasonality in these time series. You can train at home. You can take any other variable. Yes. Natural increase, immigrants, total increase of inhabitants in the Czech Republic. Yes, you can use any other time series and train to calculate chain and base indices. It's very easy, and that's all. Okay, and now very complex example. We'll use data about the development of average gross monthly wages in the Czech Republic, quarterly data. You know these data set. We'll check sheet 3. From the previous seminar, you remember that I draw a picture, a figure for you about this development. You could see the trend, you could see deterministic seasonality, and on observation of year 2008, you could see the start of recession, of the change of the macroeconomic cycle. So today we will use this data set and using additive decomposition we will estimate appropriate regression model. So we'll fit the trend and the seasonality. Finally, on the basis of this regression model, we will calculate a prediction, the forecast of average gross monthly wage in the Czech Republic on observation from first quarter of year 2013 to fourth quarter of 2013. So 4 estimates, 4 forecasts. We will check our formulas and what is necessary for us. We know that y in time t, yes, y in time t, so the time series is equal to trend, seasonality and macroeconomic cycle. But you know that modeling of macroeconomic cycle is very difficult, very complicated, only by one equation model. Yes, so there is a simple approach. We will use a regression approach to seasonal component with linear trend only. Yes, length of seasonality is 4. We have quarterly published data, quarterly time series. So y in time t is equal to trend in time t plus seasonality in time t plus error component in time t, and that's all. Yes. We can practice on the whiteboard, but how can we model trend, linear trend? Do you remember classical linear regression? Y is equal to b0 plus b1 x, and that's all. Yes, this was regression line, classical linear regression function, a line, intercept and slope. Now we have linear trend only, so we need B0 and B1. Yes, B0 and B1 time t. In our situation, y in time t is equal to B0 plus B1 t time. Yes, so you can see it's the same. Yes, but instead of independent explanatory variable x, we are using t time. Yes, linear development of time. How can we model seasonality? We'll use approach using dummy variables. Dummy variables. We have 4 quarters, so we need 4 dummy variables. Yes, variable x1 in time t, variable x2 in time t, x3 in time t, and x4 in time t. What is a dummy variable? Variable x1 in time t is equal to 1 in the situation that we have first quarter of the particular year. Yes, first quarter of the particular year, and this variable is equal to 0 in all other cases. Yes, in all other cases. Okay, yeah, so x1 in time t is equal to 1 in the case that we have first quarter, spring, yes, and this variable is equal to 0 in all other cases. We have other variable x2 in time t, and this variable is equal to 1 in the situation that we have a second quarter of the particular year, and this variable is equal to 0 in all other cases. I will use only shortcut in all other cases. Yes, in all other cases. Another variable x3 in time t is equal to 1 in the case that we have third quarter. Yes, third quarter of the particular year. Yes, and this variable is equal to 0 in all other cases. In all other cases. Yes, and finally we have a variable x4 in time t, x4 in time t, which is equal to 1 in the case that we have fourth quarter, yes, of the particular year, and this variable is equal to 0 in all other cases. Okay, so what is written here, what Mr. Hellman wrote here for you. Time series is equal to trend and seasonality and some residual error component. Yes, trend can be fitted using B0 and B1. Yes, intercept and slope of the regression line. We are using 4 parameters. Yes, necessary for 4 dummy variables, x1, x2, x3, x4. But this regression model, yes, is estimated by least squares method. Yes, least squares method. And imagine that you have a vector of explanatory variables. There will be vector b0. Sorry, I will use another marker. b0, yes, b0, b1, and other vector of sd1, sd2, sd3, and sd4. Yes, at least this will be entry data. Yes, for this least squares method, and You can imagine the structure. You can imagine the structure of the data set of this dummy variable. Please check the Microsoft Excel sheet 3 as data set. I will set here, I don't know, for example here, column x1 in time t, yes, variable x1 in time t. Variable x2 in time t will be here. Variable x3 in time t will be here. And variable x4 in time t will be here. I will use indices, format cell, subscript, okay, format cell, subscript, format cell, subscript, okay, and format cell, subscript, okay. So this is the structure of our 4 dummy variables, and according to this system, yes, value 1 in case of variable x1 in time t is equal to 1 in the case that we have first quarter. So we have observation from first quarter of 1995, second quarter 1995, third quarter 1995, etc. And we will finish this fourth quarter of 2012. So the structure here, the combination here will be 1 0 0 0, 1 0 0 0, 1 0 0 0, etc. Yes, 1 0 0 0, 1 0 0 0. Yes, and you can continue. Another variable, x2 in time t. Value 1 is in the case that we have a second quarter of the particular year. So combination 0, 1, 0, 0, 0, 1, 0, 0, and you can continue. Third variable, yes, value 1, so the position of the third quarter of the particular year. So combination 0, 0, 1, 0, 0, 0, 1, 0, and you can continue. And finally, for dummy variable x4 in time t, so combination 0, 0, 0, 1, 0, 0, 0, 1. And we can continue. So this will be repeated. Data will be repeated to the end. So copy and paste to the end, yes, paste. So there is deterministic combination, yes, deterministic data is repeated to the end. So parameters, coefficients, yes, SD1, SD2, SD3, SD4, yes, we have 4 variables. We will estimate 4 coefficients, 4 parameters. There is a vector of constants, yes, vector of intercepts. I don't know what will be here, yes, some values, yes, some values. B1, slope, yes, and there we have some input part. Probably Mr. Hellman said to you that least squares method, yes, least squares method is very sensitive on correlation of regressors, correlation of input data. If we use these 4 variables, there will be perfect linear dependence, perfect correlation between these 4 columns and, for example, column of constant. As you can see there you have some values, constants, and there is a structure, deterministic structure, yes, with the perfect position of values 1, values 0s. Least squares method will not be able to estimate the parameters, estimate the coefficients of this regression model. So we have a deal that one dummy variable is omitted, yes, is not included to the model, and we are solving one equation with one unknown. Yes, one equation with one unknown, and unknown variable will be calculated, estimated later. Yes, on the basis of formulas which are written in the formula sheet. So one dummy variable, for example, winter. Yes, for example, winter will be omitted. Yes, winter will be omitted, and we will solve one equation with one unknown variable. If you check the formulas, you can see that there is B0, B1, yes, SD1x1, SD2x2, SD3x3, SD4x4, yes. This is theoretical model, but for the practical reasons, for the least squares method, practical calculation, we must omit one dummy variable. And also Mr. Hellman omitted winter, yes. So in Excel, yes, we will solve this type of regression model. So I will delete these dummy variables. I will delete the structure, yes, and our duty will be to estimate this model. yt is equal to b0 intercept plus b1t time, yes? This will be linear trend plus Mr. Hellman using A or alpha, yes? A1x1, A2x2, A3x3. So A1x1 plus A2x2 plus A3x3. Yes, this will be model error term, yes, plus epsilon or E in time t. So this is the model, and we will continue using this model, yes, this one in the middle. So if you check my Microsoft Excel, I created here 4 dummy variables, but we know that this G column, yes, this G column will be omitted, so I will delete this G column, yes, I don't need this G column. Delete. For the purposes of the calculation of this model, we need time variable t. Yes, linear trend. What is it? Linear trend. Linear increasing of observations. Yes. How can we imagine the linear increasing of observation? Observation 1, 2, 3, 4. It's linear increasing. Yes. So we can set here time t. Yes. Observation 1, 2, 3, etc. Yes, and you will see that we have 72 observations in total. Yes, this time series, yes, t is equal from 1 to capital T. Yes, in our situation, t is equal from 1 to 72. Yes, 72 observations, 72 quarters, yeah, the last quarter is fourth quarter of 2012, average age in the fourth quarter of 2012, 27,170 Czech crowns, yes, okay, so there we have prepared the structure. In formulas, there is a way how we will continue. Yes, we will calculate 3 coefficients A. Yes, A1, A2, A3. So I will write here the formula for the recalculation of 3 coefficients to 4 coefficients. Yes, we must calculate A with stripe, A mean, yes, A1 plus A2 plus A3, yes, and this will be divided by 4, yes. A1, A2, A3, divided by 4. I will zoom this document, yes, okay, and after we will calculate some seasonal factors. Yes, seasonal factors which are denoted here SD, SDJ. We have 4 quarters, so we will calculate 4 seasonal factors. And now we calculated A1, A2, A3. Yes, okay. So SD1, SD2, and SD3 will be calculated in the same way. Yes, SD1, SD2, SD3 will be calculated like original value, yes, original value of A1, A2, A3, A1, A2, A3 minus this A mean, yes, minus this A mean, minus this A mean, minus this A mean, yes, and we omitted winter, yes, winter was omitted, so SD4 is different, yes, SD4 is different, SD4 is different. This is equal to minus A with stripe, yes? So only this one is different. SD1, SD2, SD3 is calculated like original value, yes, original estimated value from Microsoft Excel, minus this A with stripe. Okay, so what now? We must use least squares method, yes. We don't have formulas for manually calculation of these parameters. It is possible, yes, but it will spend a lot of time. Today we will use Excel, yes. Everything is prepared. I will check Microsoft Excel. There is variable y in time t, yes. There we have a dependent variable, time series, yes. Values of the time series. Time variable t and three seasonal dummy variables, yes. Okay. So the data sheet is prepared. We must use Microsoft Excel, but today I'm for the first time in this classroom, so if I click on data leaf, I don't have installed data analysis, yes, here in the right top corner of the data leaf. So we must install analysis toolpack, so you can click on file button. Yes, there is file button, and we have here options. Yes, options. So if you click on options, there we have Excel options, and there we have add-ins. Yes, add-ins. On the bottom of this small window, we can manage Excel add-ins, and there is Go button with 3 dots. So please click on this Go button with 3 dots, and find here Analysis Toolpack. Select Analysis Toolpack and click on OK. Yes, OK. And you will see data analysis on the data leaf. Yes, leaf. Data analysis. Switch on this data analysis. Data analysis. And you will see small table where we can find regression. Yes, regression. Okay. Regression, okay, and now we already seen this table, yes? Input y range and input x range. Dependent variable is only one. In our situation, average gross monthly wages, yes? Variable y. Independent variables, explanatory variables, the time, and dummy variables. So the time t, and variable x1, x2, x3, yes? T, x1, x2, x3. So 4 independent, 4 explanatory variables. I will select also the labels. Yes, so input y range, I will select from the cell B1 to cell B73. Yes, from B1 to B73. From B1 to B73. Input x range. Input x range from cell C1. Yes, from C1 to F73. Yes, you can see all 4 columns. I also selected labels, so please don't forget select labels here. Labels. Yes. Okay, everything is prepared. So you click on OK. You will see sheet 4. Yes, sheet 4. And there is output, regression output. I will zoom this document. And I will delete what is not necessary for us. Yes, I will zoom this document and what is not necessary. ANOVA table is not necessary. Yes, I will delete this ANOVA table. I will use only 2 decimals here, coefficients, okay, and we don't need these values, yes, okay, so there is table with output. Okay, can you see this table? Intercept t, x1 in time t, x2 in time t, x3 in time t. Okay. So according to formulas of Mr. Hellman, we have A1, A2, A3, yes, and if you check the whiteboard, we are able to calculate A with stripe, yes. A with stripe is equal to, it's also possible to do it manually, yes, minus 2084 minus 2084 point something, yes, plus minus 1214, yes, sorry, there is minus, plus parenthesis, minus 1214 plus and last A3 minus 1621 minus 1621, yes, and this is divided by 4, yes, this is divided by 4. So we are able to calculate it here in Excel. A mean, yes, I will write here A with stripe, it is A mean, yes, A mean, A with stripe, A mean. I will zoom this document, okay, yes, I hope that this is clear. I will check, everything is alright. Yes, probably yes. So, it's a summation of these 3 values, yes. So, equals sign, sum these 3 values, yes, divided by 4. So result is minus 1230.10. Yes. A with stripe is equal to minus 1230.10. And now we are able to recalculate the coefficients. Yes? We have one equation with one unknown. So now we'll use original values. Of A1, A2, A3 minus this A with stripe. Yes, and we'll calculate SD1, SD2, SD3. So again, I will zoom this document. Okay. And there will be SD1, SD2, SD3. Yes. Okay. SD1, SD2, SD3. So equal sign SD1 is original A1. Yes. Original A1 minus A mean. Yes. And we can continue SD2. SD2 is original A2 minus A mean. Original A2 minus A mean. And SD3 is original value A3 minus A mean. Yes. Minus A mean. Okay. So these seasonal factors, yes? Seasonal factor for first quarter, second quarter, third quarter, minus 854 Czech crowns, 15.85 Czech crowns, minus 391.10 Czech crowns, yes? Interpretation is in crowns. And finally, SD4, yes, the omitted quarter, yes, winter was omitted. SD4 is calculated like minus A with stripe, yes. If you check formulas in PDF file, you can see that SD4, yes, SD4 is minus A with stripe. Please be careful. A with stripe is negative, so minus minus is plus, yes? Equal sign minus 1230 is 1230.10, yes? Czech crowns, yes? SD1, Czech crowns, Czech crowns, Czech crowns, Czech crowns, yes? Okay. And we can continue. What else? So we have A with stripe. We have 4 seasonal factors. We can fit the data. Yes, we can fit the data. So according to following formulas, we can fit the data. So please check Microsoft Excel, yes? There is our sheet 3. There we have empirical data, time variable, dummy variables, and we will continue here. I will write here, I will copy here seasonal factors, yes? Deterministic seasonality, deterministic seasonal factors. These factors, these values, yes, are repeated almost in the same way every year because of changing of quarters, yes? Deterministic seasonality. So SD J, yes, SDJ, SDJ, format cells, subscript OK. Okay, so deterministic seasonality, sheet 4, yes, You can see SD1, SD2, SD3, SD4. Copy and paste without formulas. Copy, Control C, and sheet 3, paste special, paste values. Yes, paste values without formulas. Yes, paste values only. So paste values. I will use only 1 or 2 decimals. 1 decimal is enough. And I will copy these values and paste to the end. Yeah? This is deterministic seasonality. Deterministic seasonality. Okay. Now we can continue. We will fit the trend. Yes. Trend is a linear function, probably increasing in this case. Yes. In the case of development of average wages. In formulas, there is written that trend can be fitted like B0 star plus B1 time t plus particular deterministic seasonality, yes, seasonal factor. B0 star is equal to B0 plus A with stripe, yes. So we need to calculate here in sheet 4. There will be calculated also B0 star. Yes, there will be calculated B0 star. B0 star. Okay, and B0 star is calculated like original B0. B0 is intercept, yes, 9,048 Czech crowns, yes. This value intercept plus A mean, yes. Intercept plus A mean. This will be corrected B0 star, yes. So intercept is equal to B0, yes. T is equal to B1, x1 in time t is equal to A1, x2 in time t is equal to A2, and x3 in time t is equal to A3. Yes? You can use this screenshot. Yes? You can use this screenshot. It's important. So, fitted trend. Again, I will return to sheet 3. Yes? And fitted trend. TR in time t, yes, trend in time t. Okay, formulas, B0 star plus B1 times t, yes, so fitted trend will be here. Okay, so equal sign, yes, trend in time t. So now I need sheet 4, yes. Where is B0 star? So I will click on sheet 4 and I am in the sheet 4 and I will select B0 star 7,818 and I will use dollars F4 function 4 on your keyboard. Yes, function 4 dollars plus B1 times t. Where is B1? 254.68. Yes. So plus this value. Yes. Again, function 4. You must lock the cell. Yes. So function 4, F4 button times t. And t, variable t, is in sheet 3, yes, sheet 3. So I will click on sheet 3 and time is here, yes. Okay, it's visible. Okay. In sheet 4, yes, with dollars, you must use B0 star, yes, plus in sheet 4, yes, you must use B1 with dollars, yes, because B0 star and B1 are constants, yes, coefficients are still the same. B1, yes, from sheet 4, times in sheet 3, C2 time variable, yes. This is without dollars, this is not fixed, yes. Okay, so enter, and there is fitted trend, yes, there is fitted trend. And I will copy these formulas to the end, yes, I'll copy these formulas to the end. And now, we will verify if everything is alright, yes. Trend must be linear trend. If I delete this whiteboard, yes, wait a second, I will delete the whiteboard. Okay, whiteboard is ready. So, do you remember? This is chart, there is time, there is my variable y in time t, yes. Linear trend, yes. Linear trend is the line, yes. This is increasing linear trend. Seasonality, yes. Seasonality, periodical fluctuation around trend. We know that our time series, yes, our time series probably also contains macroeconomic cycle, yes, cyclical component, because there is increasing trend. There is year 2008, yes, 2008, economic slowdown, yes, and after the development is not so much increasing, and around this trend, yes, you could see seasonality, yes. So probably this is a real situation, and we modeled this. The line is trend, yes, TR, and periodical fluctuations around the trend, this is seasonality, yes. So trend and the seasonality. We have here seasonality and the trend, yes. SD, seasonality, and trend. We can draw a picture, yes, if you want. We can draw a picture of seasonality and trend. I can select this column, yes. I can select this column. I can use insert button. We have here charts, yes. And there is a line chart, yes. Line chart, classical line chart. Okay, SD, yes, seasonal factors for the particular quarter. I can use a smaller font, with 6, for example, 4, and bold. Okay, and quarters, yes, I will use design, select data, horizontal category, axis labels, edit, and I will use these quarters from first quarter 1995 to fourth quarter 2012. Okay, okay, and I will format data series. I will use timer line, yes. I think that this is clearly visible, yes, clearly visible. Okay, periodical fluctuations, yes. I will check if you are able to see this chart. Okay, periodical fluctuations. around the trend, yes, deterministic seasonality, SDJ. We will continue with strength. Yes, I'll show to you the proof that we have correctly fitted linear trend. So I will move this chart, yes, on the right side of the screen, and I will try to create a chart of trend, linear trend. Result should be line, yes, increasing line. So trend in time t, I will use all data. All data, insert charts, yes, and then we have line chart. Okay, this is trend. I will try to use the same formatting, and the same formatting for this chart. Okay. Smaller font, 4 points only. Okay, bold. I will use instead of 1, 2, 3, 4. Yes, I will use on the position of x axis quarters. Yes, the labels. So there is design button, select the data, horizontal category axis labels, edit, yes, axis labels range from first quarter 1995 to fourth quarter of year 2012, okay, okay, yes. So I will try to show you both charts, yes. Okay. So maybe thinner this line. In the case of right chart, I used 1.25 points. Yes. Here I will use format data series instead of 2.25, 1.25. Okay, and now I have, wait a second, no, one chart, second chart, perfect. Okay, so there is the line, the trend, linear trend, B0, B1, intercept and slope, yes, linear increasing. In the right chart, you can see deterministic seasonality. If we calculate the summation, yes, y in time t fitted, yes, fitted data are equal to tr in time t plus seasonality in time t. So we will fit the data. Yes, we will fit the data. Fitted data in your formulas are yt with hat, yes, yt with hat. Okay, so in Excel, I will move these charts, yes, I will move these charts to the right side, and here in the next column we will calculate y in time t hat, yes, okay, y in time t hat, format cell, subscript, okay. Okay, how can we fit the data? Calculate the summation of trend and seasonality. Yes, so fitted trend, yes, plus fitted seasonality. Okay, that's all. Yes, that's all. Enter, and we will copy the formulas to the end. Okay, and now we will compare the differences. Empirical data and fitted data. Yes, empirical data original observed data set. Yes, where we have data set here. Y in time t. Yes, Y in time t. I will draw a chart. Insert button, line chart. Yes, classical line chart. I will use smaller font for points. I will use bold. Yes. I will delete this name of the chart, and instead of observation 1, 2, 3, 4, 5, yes, x-axis, I will use labels, observation, quarters, yes. So there is design button, select data, horizontal category axis labels, edit, yes. And I will use these observations. The first column, okay, okay. So you can check the development of average gross monthly wages in the Czech Republic from first quarter 1995 to fourth quarter of 2012. Yes, maybe I can use a little bit larger font in this situation. 6 points. Yes. Okay. So there we have empirical data. Increasing trend. Yes. Periodical fluctuations around the trend, repeated almost in the same way every year, yes, because of changing of seasons. There is year 2008, yes, and probably you can see economic slowdown, yes, the change in macroeconomic cycle. This issue, yes. Okay, so there we have empirical data, and we will compare these empirical data with our model, with fitted data. So I will use this column y in time t hat. Yes, y in time t hat. I will select this column, all this column, yes, all this column. I will use copy, Ctrl C. I will click to the chart and paste, Ctrl V, yes. Copy data and paste to the chart, yes. So copy, Ctrl C, and there is the chart. I will click to plot area, yes, and paste. You can see blue curve and orange curve, yes, empirical data and fitted data by my model, yes. You can see that my trend, orange development, yes, still increasing, and blue curve, yes, started to decrease, slowly decrease because of change of macroeconomic cycle. So in this situation, there will be better to use instead of linear trend, parabolic trend. Yes, quadratic regression function. Do you remember quadratic regression function? B0 plus B1t plus B2t squared. Yes, quadratic regression, and you will see this development. But you don't have this issue, you don't have this part in your formulas, so I will not show to you this way. Yes. So probably our model is quite good. Yes. We are able to fit the data set, and what else was written here? So using additive decomposition we estimated appropriate regression model. We used only linear trend and deterministic seasonality, yes? On the basis of this regression model, calculate prediction forecast of average gross monthly wage in the Czech Republic. So forecast, where is my data set here? On these 4 positions, yes. So first quarter of year 2013, first quarter, 2013 second quarter, yes. 2013 third quarter, and 2013 fourth quarter, yes. We don't have these observations, yes. This is unknown for us, yes? But we are able, according to our model, yes, we are able, there is the end, there is the end of observation. We are able to extrapolate, yes, we are able to extrapolate the trend, and we are able to extrapolate the seasonality, yes, because we have the basic idea about development, yes, we have estimated parameters, so we know that we must estimate observation 73, 74, 75, 73, 74, 75, and 76. 73, 4, 5, 6. We know what is its seasonality. Yes. Maybe I will use view freeze panes, yes, and you can see, you know which column I'm using, yes. G column, SV, seasonality. Seasonality is repeated every year, almost in the same way, yes, in the same intensity, yes, because of changing of seasons, spring, summer, autumn, winter, yes. So I can copy, yes, I can copy these 4 values, copy, paste, yes. So you have an idea about seasonality, yes. It's still the same because it's only deterministic model. Trend, you are able to extrapolate the trend, yes. Can you see the line? There is the line, yes. You are able to extrapolate the line, yes. We have B0, B1, and time variable t, yes. So there is time variable t, there is our trend, yes, you can see, there is a function, so we just use different values of time, and we will extrapolate the trend. So you can copy these values, and there you have extrapolated trend, yes. And trend and seasonality are the forecast, yes. So can use hat, yes. Trend and seasonality is the forecast. So first quarter, second quarter, third quarter, and fourth quarter will be calculated here. There is equal sign trend plus seasonality. Yes, trend plus seasonality, and we have here forecast on year 2013. So 25,000 25,555. Check grounds, yes? This is first forecasted value. Second forecasted value, 26,680. 26,680. I will not use decimals, yes? I will use all crowns. Third quarter, yes, third forecast, 26,528. 26,528. Yes. And the last estimated forecast, 28,404. 28,404. Okay. So you can see that it's not difficult, but it spends a lot of time, but results are very useful. Yes, you are able to calculate simple forecast of the time series. Yes. Okay, so that's all. You could see decomposition of time series, the simplest way of decomposition, because we decompose the time series only to trend and the seasonality. If we use polynomial functions, yes, we are able to modify the trend, and probably on this situation of average wages, yes, we will obtain better results if we use quadratic regression. But it's a topic of another subject, another courses. So this is the end of sixth seminar. According to instruction of Mr. Hellman, in seminar 7, we should write a first midterm test, but nobody knows. Nobody knows at this moment when you will be allowed to write the first midterm test. Nobody knows. So be at home, study statistics, and wait. Yes, we will send you instructions later. So this will be end of sixth seminar. Next week we will continue with seminar number 7. Mr. Hellman probably already sent it to you and other presentations. So we will continue using presentation number 7. So thank you for your attention, and I hope that I will see you next week in week number 7, 7th seminar. So bye bye.